I am Ahaan, and the topic for my project for Raman Awards is dimensional analysis. Dimensional analysis is the analysis of the relationship between two physical quantities by identifying their fundamental dimensions. In this video, we will use dimensional analysis to derive the formula for drag. In fluid dynamics, drag is a force acting opposite to the relative motion of a body in its surrounding fluid. In order to derive the formula for drag, let us conduct some experiments to identify the factors affecting drag. The aim of the first experiment is to study the effect of the surface area of a body on drag. In this experiment, I will release this toy car on the ramp and observe the distance it travels. I will now mark the distance it has traveled with the blue chalk. I have now attached this sail to the toy car and I will repeat the same experiment. I will mark the distance it has traveled with the green chalk. We have observed that due to the increase in surface area of the car, it has traveled a lesser distance. However, this decrease in distance could also be due to the additional weight of the sail. So now, I will keep the sail furled and repeat the experiment. We observe that now there is no significant change in the distance traveled. From this, we can conclude that the increase in surface area of the car due to the sail increased the amount of drag on it. Therefore, it traveled a lesser distance. In the second experiment, we will observe the effect of the velocity of the object relative to the fluid on the drag. In this experiment, I will again release the car on the ramp and note the distance it has traveled. I will mark the distance with a blue chalk. Now, as I release the toy car on the ramp, I will blow air on it using a hairdryer and observe the change in the distance traveled. We observed that as air was blown on the car using the blow dryer, the relative velocity of the object with respect to the fluid increased, causing an increase in the drag, and the car traveled a lesser distance. In the third experiment, we will observe the effect of the density of the fluid on drag. Here, I have a plastic lid to which I have tied a rubber band. As I stretch this rubber band and when I let the lid go, observe what happens. The lid travels upwards with a very high velocity when it is released. Now let us conduct the same experiment in water. In water, due to the increase in the density of the fluid, there is an increase in the drag force and the lid travels with a much slower velocity. From these experiments, we conclude that drag depends on the velocity and surface area of an object and the density of the fluid. Based on this, we can perform dimensional analysis, the calculation for which is given here.